Welcome to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject that I am covering in my lecture series is microprocessor. Code is KCS 403. I am covering second unit, and today the topics that I will cover are instruction formats of 8085, addressing modes, and assembler directives. So what are instruction formats? Whenever you consider any instruction of 8085, you will see some instructions are very small in length, some are pretty long. So what is that? That is the format. Some instructions cover only 1 byte, some other cover 2 bytes, and some other cover 3 bytes. So there are basically three types of instruction formats in 8085. That is 1 byte, 2 byte and 3 byte. So before going into details, let's see what are the important terms related to instruction format. What is operation code? The operation code field in the instruction specifies the operation to be performed. So by understanding the operation code, the machine understands what it has to perform. The operation is specified by binary code, hence the name operation code or simply opcode. So machine always understands only binary language, that is the language of 0 and 1. That is known as the machine language. The source or destination operand. The source or destination operand field directly specifies the source or destination operand for the instruction. In the instruction format of 8085, the instruction, suppose the instruction is move A, B. It has B register contents as the source register and A register contents as the destination operand, because this instruction copies the content of B in accumulator, that is in A register. So in this way, this is the source operand and this is the destination operand. So if we consider any of the instruction of 8085, we will see it has either the source or destination operand or both. Now the source operand address, it is specified the address from where we have to fetch, this machine has to fetch, the processor has to fetch its data, that is known as the source operand address. Destination operand address means the address where the processor has to specify the destination operands. Means, let's see the example. In 8085, the destination operand address for instruction INR M is given by HL register pair. Why? Because the meaning of this instruction is increase the value of contents specified by this pointer by 1. What is this pointer? Wherever we come across the term M in 8085, it means it is being that the contents are being pointed to by the contents of HL register pair. So the memory location which is being pointed by HL register pair, this instruction is talking about that memory location. Suppose HL register pair is having 2050, H containing 20, L containing 50. So in combination it gives 2050H, suppose. Now I am writing this instruction INR M. So what will happen? At the memory address pointed to by this, suppose it is containing 40. This is the memory location pointed to by this 2050. It is containing 40. Now what will the INR M do? INR M will increase the value of this by 1. So it will go to 41. That means that M gives the memory location or the address pointed to by the HL register pair. Next instruction address, it tells the 8085 from where to fetch the next instruction after completion of execution. And in 8085 or any other microprocessor, program counter is the register which holds the address of next instruction. Now we come to instruction formats. So there are three types, as I have already told. Like the first byte is always the opcode, the 2 byte instructions, the second byte is always the usually data, and in the 3 byte instructions the last 2 bytes present the address or the 16-bit data. So this is the format. So let us consider the first format, that is a 1 byte instruction. In this the 1 byte contains only opcode, no operand is there. For example, move A comma B, whose opcode is 78H. So this is the 1 byte. So in combination, move A comma B is the 1 byte instruction. So this instruction will copy the contents of B in the accumulator. So this is 1 byte instruction. So when there is no immediate data present or any address present, then it will be of 1 byte only. And if the data is present, 16-bit data is present or 8-bit data is present or 16-bit address is present, then the format will be 2 bytes or 3 bytes. Let's see. In the 2 byte instruction, the combination of 2 bytes gives opcode and operand. MVI B, 02. The opcode for this instruction is 06H and it's always followed by a byte data 02. So the opcode is a combination of MVI B, some destination, and the second byte is always the data specified in the instruction. So what will this instruction do? This is the immediate addressing mode, and in this 02 is the immediate content. So this 02 will move to B, register B. So this is what is happening in this instruction. So it is a 2 byte instruction. First byte is the opcode and the second byte is always the operand, that is the immediate data specified in the instruction. 3 byte instruction. In this, the first is the opcode, second byte is the operand and third byte is also the operand. So second and third byte may be the 16-bit data or the 16-bit address. For example, jump 6200H, the opcode for this instruction is 63H and is always followed by 16-bit address, because this is 16-bit address. And what is this instruction doing? This is transferring the program control to this memory location. Jump 6200 will transfer the program flow to 6200 memory location. So this is a 3 byte instruction. First is the opcode and second byte is the lower order address and third byte is the higher order address. So this is the higher order address and this is the lower order address. So this is how we make the formats. Suppose I am giving you any instruction, so how will you tell me that what will be the instruction format for this particular instruction? So let's see. So when I am talking about the registers, so this is the code specification and accordingly the registers can be mentioned. So suppose for the B register the code is 000, for C the code is 001, for D register the code is 010, for E the code is 011, for H and L it is 100 and 101, for M where the indirect memory is pointed to, then 110 is the code, and for accumulator the code is 111. When we talk about the register pairs, the code is 00 for BC, 01 for DE, 10 for HL, 11 for accumulator and flag, that is the program status word. This is the combination of accumulator and flag register, and this is stack pointer. Now we talk about the operation code of some general instructions. These are the most general instructions used. MVI R comma data. So what will be the opcode? So as we know that for MVI R comma data, it is 2 byte instructions. Yes. So I have already discussed that this is 2 byte instruction. So first byte is the opcode and second byte is the operand. Operand is data. immediate data. So I am talking about opcode here. For the opcode of MVI R, comma data, it is given by 00 DDD. DDD here denotes the destination. Which destination? Here. Here, if this is A, R is A, so then this DDD will get replaced by 111. Yes. If here R is suppose C, then this DDD will get replaced by 001. So this is how the format is specified. So suppose I give you MVI A, comma 02H. Now, what will you write? What will be the instruction format for this? So from this table, we can mention 00 DDD means for A it is 111. Now 110 it is already mentioned 110. Now for 02 0 0 0 0 0 0 0 1 0. So this is 0 and this is 2 and this is the opcode for this instruction. So in total these are 2 bytes, this is 1 byte and this is second byte. So in this way we can, if we have the knowledge of these tables mentioned here, if we have the knowledge of the opcodes, then we can easily write the format for any given instruction. Similarly, for LXI register pair comma data, for this the opcode is 000 DD means destination. Here the destination means register pair, this register pair. So in this, if it is HL or suppose it is DE, so here 01 will be replacing DD and then 0001. So if I give you this instruction LXI D comma 02 again, yes, so 0204, suppose I give you this. So what will be the opcode for this? Let's see. So LXI D comma 0204. So in this, first of all I will consider this opcode 00, destination is DE. So for D 01 0 0 0 1. So this is first byte. Second byte, lower order byte, that is 04 0 0 0 0 4 0 1 0 0 0 2 0 0 0 0, higher order byte 02. So this is the first byte, this is second byte, this is third byte. So this is the 3 byte instruction. And similarly for move RD comma RS, suppose this is destination register and this is source register. So for destination here DD, suppose I give you move A comma B. So what will be the format? 0 1, here 0 1. DD means destination means A here, 1 1 1, sorry, this 3 bits for destination and 3 bits for source. So what is the source here? Source is B, and for this B 0 0 0 is the code. So 0 0 0. So here 0 1 already specified. DDD means destination A. The code corresponding to A is 1 1 1 and the code corresponding to the source CSSS is 0 0 0. So here 0 0 0. So this is the format, this is the opcode for move A comma B. So in this way, this is how we will find out the instruction formats for any given instruction. Now the data formats. The address is the 16-bit unsigned integer number used to refer a memory location. These are some important terms which we should know. So when we talk about the numbers or data, the 8085 supports the following numeric types. Which are the numeric types? Signed integer. So it's either a positive number or a negative number. In 8085, 8 bits are assigned for signed integer, in which most significant bit is used for sign and remaining 7 bits are used for sign bit, which indicates the positive number, whereas sign bit 1 indicates negative number. Now the unsigned integer, when we talk about unsigned integer, it supports 8 bits unsigned integer. BCD means binary coded decimal. This stands for the binary coded decimal number, which ranges from 0 to 9. Characters, it uses ASCII code to represent characters. It's a 7-bit alphanumeric code that represents the decimal numbers. Now we come to addressing modes. So addressing mode means the way of specifying the operand in the instruction. This is the addressing mode. So whenever you look at any of the instruction, some instructions are having the operands with the immediate value, like we saw in this MVI A, 02 H. So this is the immediate value. But if we write move A, B, so this is the register in which the contents are stored. If I write move A, M, so these are not the direct contents which will be copied to A, but these are containing the pointer to some contents. So in this way, there are different ways of specifying the operands in the instruction. So for 8085, there are 5 ways of specifying the operands, and these have been named as the 5 different addressing modes, which are as immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and implied addressing mode. One by one, we will go into the details. When we talk about the immediate addressing mode, the first of all, the recognition for this mode is the term I. Here MVI, LXI. So wherever you see I in the instruction, it means it is the immediate addressing mode. In the immediate addressing mode, 8 or the 16-bit data is specified as a part of instruction. It is already mentioned in the instruction. So here we'll have the examples. MVI A, 20H means 20 is the direct content which will be copied to accumulator. Here MVI M, 30H means the 30, which is the direct content, it will be copied to the memory location which is being pointed to by HL register pair. So this is what this instruction mentions. Now LXI SP, 2700, the SP stands for a stack pointer. It means the stack pointer is being immediately stored with some content. What is the content? This is the content. So after the execution of this instruction, the stack pointer will get updated with this content 2700. Now suppose I am writing LXI D, 10FFH, it means DE register pair I am talking about. So in the DE register pair, this content will be copied 10FF. So 10 will go to D, higher order register, and FF will go to E, that is the lower order register. So in all these instructions, these immediate contents are present in the instruction itself. In the register addressing mode, and in the operand is given in the register mentioned in the instruction. Means move A, B, here the operand is in the B. So it moves the contents of register B into the accumulator, or it can be or we can say either the destination or the source or both, they can be in the register. SP, what will it do? It will move the contents of HL register pair to stack pointer. So here again the operands are the registers. Add C means it will add the contents of C register with accumulator and the result will go into accumulator. So here again the operand is C, but if I would have written it as ADI 32, H, it means it is the immediate addressing mode, and it will add the contents mentioned in the instruction directly with the accumulator, and the result will go into accumulator. So in here, this is the register addressing mode, where either the source or the destination or both, they are registers. Direct addressing mode, here the address is specified in the instruction, that is 2000H or 3000H. These are the addresses. Let's see. What will this instruction do? This will load the contents present at this address into the accumulator. It will load the 8-bit contents of memory location. Which memory location? This memory location into accumulator. So here directly the memory address is mentioned in the instruction. Now SHLD, it will store the contents of HL register pair into 2 consecutive memory locations mentioned here directly. That is, it is again considering the memory addresses mentioned in the instruction. So what will it do? It will store the HL register pair contents into 3000H. So it will copy the contents of L register pair into 3000H, and it will copy the contents of H register pair into 3001H into the higher memory location. So in this way it will store the contents of HL register pair into memory location directly. So here, since the memory locations are directly mentioned here, this is not the immediate data, these are the memory locations. So that's why this addressing mode is known as the direct addressing mode. In the indirect addressing mode, the memory address where the operand is located location is specified by the contents of register pair. Let's see how. Move A, M. This is not the direct address, but this is mentioning that the contents are being specified by the some memory location which is being pointed to by address HL register pair. So it will move the contents of the memory location pointed to by the HL register pair to the accumulator. So here directly address is not mentioned, but the pointer to the address is mentioned. Again, LDAXB, it means it will load the accumulator with the contents of BC register pair to the let me explain this. So this is LDAXB. It means it will load the accumulator with the BC register pair because X is here. It means some register pair is working in the instruction. But how the BC register pair contents can be stored in A, because BC is 16-bit and A is just 8-bit. So how will it happen? It doesn't mean that the contents of BC will be directly stored in A, but it means that BC contents will act as a pointer to some memory location, and that memory location will be from the contents of that memory location will be copied to A. Suppose BC contains 2040. So this will be treated as a pointer, and the contents at this memory location will be loaded to accumulator. So this is what is happening. So directly no operand is mentioned, directly the immediate data is not mentioned, directly the address is not mentioned, but the register pair which is given as an operand, which is mentioned as the operand, it will act as a pointer to some memory location. Again in this example LXIH, that is load the immediate, it will load the immediate HL register pair with the address of the memory location. So again this is another example. Implied addressing mode, here no operand is mentioned in the instruction, and so that's why it is known as the implicit or implied addressing mode. Example CMA. CMA is doing what? It will complement the contents of accumulator. CMA, complement the contents of accumulator. So by itself it is very clear from the instruction that the contents of the accumulator have to be complemented. Now again RRC, that is the rotate the accumulator A by right to right by 1 bit. RLC, it will rotate the accumulator by left by 1 bit. So by itself there is no mention of the operand exclusively, but it is implicitly understood that what is the operand in this case. So such instructions are categorized under implicit or implied addressing mode. So when we talk about the assembler directives, there are certain programs, there are certain instructions which are given as the directives to the assembler at the time of execution of the source program. So let's see, these are also known as the pseudo instructions or pseudo opcodes, because these are not opcodes, but these are the certain instructions which are given to the assembler. So these are a few assembler directives. Let's see. Define byte. So here the bytes can be defined using this directive under some variable name. Here define word, some word means 16-bit data can be allocated to some memory marked by this variable name mark, and specifies the end of program. This is the directive used at the time of program termination. EQU, it is used to equate the variable to some numeric value, means wherever the done, with this example it can be understood, wherever the done variable is used, it will be treated as the value 10h. So it is used to define some numeric value, or we can say the constant to the variable. Macro, it represents the beginning of the macro, and M represents the end of the macro. ORG, it means it is used to specify from where we have to start our program, we have to start our code. So that writing the ORG 1050, it means the program, our next code should start from this location. So that's all for today. So today we discussed addressing modes, assembler directives, and instruction formats for 8085. Thanks a lot for today.